Hi friends and neighbors, welcome to the 6th ShepNotes video on a series covering statistics and probability. This video will cover the permutations of a number of objects n when taken in groups of r. A permutation is defined as the number of possible ways to arrange a number of n objects when each object is only used once and the order of the objects is important. Here are some examples. With 3 objects, there are 6 different possible permutations. With 2 objects, there are 2 possible arrangements or permutations. And with 1 object, of course, there's only 1 permutation. With 0 objects, there is 1 possible arrangement, and that is with no object. To summarize, there are n factorial ways to arrange n objects. Each way is called a permutation. 3 factorial is equal to 6, and that means there are 6 arrangements for 3 objects. 2 factorial is equal to 2, and that means that there are 2 arrangements for each object. And 1 factorial equals 1, which means there are 1 arrangement for 1 object. When there are 0 objects, there is only 1 possible arrangement, and that is with no objects. The number of possible distinct arrangements of n objects taken r at a time is called the permutation, and it is given by the formula npr is equal to n factorial divided by the quantity n minus r factorial. N is the number of choices we can choose from, and n minus r is the number of them we do not want. If you want 2 out of 6 choices, n equals 6 and r equals 2. You want all but n minus r factorial, which is equal to 6 minus 2 factorial, which is equal to 4 factorial. So, by dividing by 4, you are canceling out all of the choices you don't want, leaving only those choices you do want. 6 times 5 times 4 factorial divided by 4 factorial equals 30. In the formula for permutations, where n is the number of objects and r is the number taken at a time, the number of permutations is equal to the product of the first r terms of the factorial of n. If we want to calculate the number of permutations when we take 2 objects at a time out of a group of 4 objects, 4p2, the value is the factorial of the first r or 2 terms of 4 factorial, which is simply 4 times 3 equals 12. This is because n minus r factorial in the divisor of the formula is exactly equal to the terms we don't want to include in the calculation and can be ignored, since in this example 2 times 1 divided by 2 times 1 is equal to 1. Let's look at an example of permutations and the formula for the number of arrangements or permutations of 4 objects with n equal 4, taken 4 at a time, and with r equals 4. As shown, the number of permutations is equal to 24. Pause the video and study the formula and the 24 permutations shown below. The permutations for 4 objects taken 4 at a time is 4 factorial, which is equal to 24. Let's see what happens when we take 3 at a time instead of 4 at a time with the same 4 objects. As shown, the number of permutations is still equal to 24. The number of permutations for 4 objects taken 3 or 4 at a time from 4 objects is always the same because 0 factorial and 1 factorial in the divisor are both equal to 1. When we take 2, 1, or 0 objects at a time, r equals 2, 1, or 0, and the number of permutations drops to 12, 4, and 1, respectively. Pause the video and understand the screen before you move on. Let's take a closer look at the calculations for the permutations of 4 objects taken 2 at a time. The formula 4 factorial over the quantity 4 minus 2 factorial is equal to 4 factorial divided by 2 factorial, and that in turn is equal to 4 times 3 times 2 times 1 divided by 2 times 1. Notice that 2 times 1 in the numerator and denominator are marked in red. Since they are equal, they will divide and cancel out, being equal to 1. So now the expression is reduced to 4 times 3 times 1, which is equal to 12. The number of permutations for n objects, in this case 4, are given by 4 factorial equals 4 times 3 times 2 times 1. Since only 2 objects are taken at a time, only the first 2 factors of 4 factorial are used by canceling out the last 2 factors, 2 times 1, by dividing 4 factorial by 2 factorial, so the terms 2 times 1 can be ignored. Pause the video and study the formulas and description here to see how the permutations for 4 objects taken 1 at a time and also for 4 objects taken 0 at a time can be calculated. With permutations, order is important. At the upper left, there are 3 permutations of the 3 colored objects, since each group is arranged in a different order. With combinations, order is not important. Each group of objects at the upper left is the same combination of objects, since the only difference between the groups is the orders of the objects in the groups. Hi friends and neighbors. Thanks for watching the 6th ShepNotes video on a series covering statistics and probability. This video covered the permutations of a number of objects n when taken in groups of r.